Welcome back to my video series working through the Sonic Pi tutorial. In this video, section 5.7, Thread Synchronization. Thread Synchronization. Once you have become sufficiently advanced live coding with a number of functions and threads simultaneously, you've probably noticed that it's pretty easy to make a mistake in one of the threads, which kills it. That's no big deal because you can easily restart the thread by hitting run. However, when you restart the thread, it is now out of time with the original threads. Inherited time. As we discussed earlier, new threads created within thread inherit all the settings from the parent thread. This includes the current time. This means that threads are always in time with each other when started simultaneously. However, when you start a thread on its own, it starts with its own time, which is unlikely to be in sync with any of the other currently running threads. Queue and sync. Sonic Pi provides a solution to this problem with the functions queue and sync. Queue allows us to send out heartbeat messages to all other threads. By default, the other threads aren't interested and ignore these heartbeat messages. However, you can easily register interest with the sync function. The important thing to be aware of is that sync is similar to sleep in that it stops the current thread from doing anything for a period of time. However, with sleep, you specify how long you want to wait, while with sync, you don't know how long you will wait, as sync waits for the next queue from another thread, which may be soon or a long time away. Let's explore this in a little more detail. We have in thread do loop do queue tick sleep one and end. And then in another thread, we have in thread do loop do sync tick sample drum heavy kick and end. Here we have two threads, one acting like a metronome, not playing any sounds but sending out tick heartbeat messages every beat. The second thread is synchronizing on tick messages, and when it receives one, it inherits the time of the queue thread and continues running. As a result, we will hear the drum heavy kick sample exactly when the other thread sends the tick message, even if the two threads didn't start their execution at the same time. Let's play with this. This one will not end up, except that, here, let's sleep 6. Let's sleep 5, so we're going to wait 5 seconds and then we should start hearing this one. It's queuing. And now it's syncing. Neat. Let's see. I don't know if I read this already, but I'll read it again. As a result, we will hear the drum heavy kick sample exactly when the other thread sends the tick message. Yeah, that's what we heard that. Even if the two threads didn't start their execution at the same time. Here we have another one. That naughty, so the example here is just doing basically what I did. That naughty sleep call would typically make the second thread out of phase with the first. However, as we're using queue and sync, we automatically, we automatically sync the threads by passing any accidental timing offsets. Queue names. You are free to use whatever name you'd like for your queue messages, not just tick. You just need to ensure that other threads are syncing on the correct name. Otherwise, they'll be waiting forever, or at least until you press the stop button. Let's play with a few queue names. All right, let's start again. We have in thread do loop do queue foo comma bar comma baz dot choose sleep 0.5 and end in thread do loop, I think I see where this is going, loop do sync foo, oh interesting, sample elect beep, not boop, beep, and end. For the next one we have in thread do loop do sync bar sample elect flip end, and then the last one will be baz in, let's get some space down here, in thread do loop do sync baz sample elect blup blup and end. Here we have, let's listen to it and then I'll read the commentary. So notice we've got different cues showing up. Bar, baz, bar. And we can see them here too. Foo, bar, baz, 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 foo, and so on. I'm seeing a lot of possibilities in this kind of a pattern. Cool. Here we have a main cue loop, which is randomly sending one of the heartbeat names, foo, bar, or baz. We then also have 3 loops syncing on each of these names independently, and then playing a different sample. The net effect is that we hear a sound every 0.5 beats, as each of the sync threads is randomly synced with the cue thread and plays its sample. This of course also works if you order the threads in reverse, as the sync threads will simply sit and wait for the next cue. Oh, that's like if you do this. I think that's the point that that thing is making. Yeah, that's pretty cool. Alright, that's it for that section. That was quicker than I thought it would be. Thanks for watching.